Hello friends, this is my second lecture in Signal System series. My name is Nishtha Verma. So the topic which I am going to cover in this lecture is our basic signals. What are the basic signals which we use in signal system? Properties of impulse function, and the few numericals we are going to do based on impulse function properties. Now basic signals. The basic signals which we generally use in signal system are first is impulse signal, unit step signal, ramp signal, parabolic signal. Now first comes a unit impulse signal. Unit impulse signal is also called a delta signal, delta function. So here you can see I have written delta n. It means it is a discrete signal. For continuous time signal, it will be represented as delta t. So it's because it is a unit impulse, that's why its magnitude we can say it is 1 at t equal to 0. This is time axis. So delta is equal to, for unit impulse function, it is 1 for t is equal to 0, or 0 when t is not equal to 0. Next is unit step signal. For unit step signal, we represent it using ut. Its magnitude is 1 and it goes up to infinity. This is your 0, this is your time axis. So you can write for unit step signal ut is equal to 1 for t greater or equal to 0, or it is 0 for t less than 0. Now next comes ramp signal. Ramp signal is rt. It is represented in this way. This is your time axis, this is your 0. So ramp signal, you can see rt is equal to, we represent it is using t square by 2. This value will be when t is greater or equal to 0, and otherwise it will be 0 when t is less than 0. So now last one is parabolic function. Parabolic function will be, we represent it using pt. So pt is equal to, you can say, t square by 2. This is 0, this is time axis. So it is t greater or equal to 0 and 0 when t is less than 0. So now the important point comes, what is the relation between these four signals? Actually these four signals are related because the signals which we have studied is impulse function, unit step signal, ramp signal, and parabolic signal. So suppose you are having a impulse signal and you want to change it into unit step signal, then you have to integrate it. And if you are having unit step, you want to change it into ramp signal, you have to integrate it. Again, if you have a ramp signal, you change it into parabolic, then again you are going to integrate it. And on opposite side, if you are having parabolic signal and you want to change it into ramp signal, then you have to differentiate it. In the same way, if you are having ramp signal and you want to change it into unit step, you will differentiate. In that way, when you are going from down to up, you have to differentiate, and when you are coming from upside to down, you have to integrate it. How this property is useful? Suppose you are having a one system and you are applying input, any input. Suppose you are applying impulse function and you are getting certain output. So suppose now in next step, it is like you have to calculate the output for input variable pt. So in that case, again you don't have to apply the parabolic function, because we know that if we integrate the your impulse signal 2 times, you will get the parabolic signal. So directly integration of the output will give you the final output. So again and again, you don't have to apply different inputs. If you have calculated the output for any one of the signal, then you can calculate the output for other signal. So now the properties of impulse function. First property, as we know, because we know that how impulse function look like. If it is not unit impulse, if it is only impulse function, then its value is infinity at t equal to 0. Delta t is there. So you can see that delta 0 value is infinite for at t equal to 0. And second property is delta t is equal to 0 for t not equal to this. We can see that only at t equal to 0 its impulse is lying, otherwise it is 0. And third property is if you have to calculate the area under curve, the value you will get is 1. Fourth property is your folding property, which we will see later. So in folding property, if you do delta minus t, you will get the same signal. And this is your sampling property. Sampling property, you can see it will look like that. We will do the numerical on this property. In the same way, it is a time shifting property. The output will be look like this. The numerical which we are going to do on these two properties. So take the numerical on sampling property. So suppose example I am taking, I have a numerical like 2t plus 1 delta t minus 3 is given, and I have to calculate the output. So first of all, what I will do, I will compare this whole equation by this equation. So you can see that if you compare, you can see that xt is equal to 2t plus 1, right? And t naught is equal to 3. So for this equation, the output will be xt naught delta t minus t naught. So if you know xt and t naught you are knowing, so you can calculate xt naught. So xt naught will become 2 into 3 plus 1, which is equal to 7. So the output, final output is xt naught, that is 7 multiplied by delta t minus t naught. Delta t minus t naught, what is t naught? T naught is 3. So this will be your final answer. Now numerical on shifting property. Example I am taking, like suppose I have numerical like limits are minus 2 to 4 t plus t square delta t minus 3 dt. If we I have to calculate this value. So first of all, you will compare this whole equation by this equation. So you can see that t1 is equal to minus 2, t2 is equal to 4, xt is equal to t plus t square, and t naught given to you is 3. So the output will be this one. So first of all, you have to check that your t naught should between t1 and t2. So you can see it is 3. So obviously 3 lie between these two limits. So now the answer will be xt naught. Xt naught means you put the value of t naught in xt equation. So what is t naught? 3. So you put this value over here. So you will get 3 plus 3 square. So what you are getting? 3 plus 9, that will be 12. So your final answer will be xt naught, that is 12. Now one more numerical. Suppose I'm having limits from minus 1 to 2 and t plus t square delta t minus 4 dt is there. So again you can say that you are getting t1 is equal to minus 1, t2 is equal to 2, and t naught is equal to 4, and plus xt, you can see you are getting t plus t square. So So I told you first you have to see that t naught should lie between the limit of t1 and t2. So you can see that 4 doesn't lie between t1 and t2. So if you remember the property, if it doesn't lie between these limits, the answer will be 0. So you can directly write the answer for this numerical is 0. You need not to calculate it. Now topics which I am going to cover in next lecture will be the basic operation on the signals, folding operation, time shifting, time scaling, various numericals which we are going to do in the next lecture. Thank you.